We didn't click the start. Sorry. One more time. Question 1 asks you which one has greatest electronegativity? A. Sodium. B. Aluminum. C. Phosphorus. D. Chlorine. So electronegativity for the element in the same period from left to right, electronegativity increase. This is group 1A, the group 2A, 3A, group 5A, group 6A. So from left to right, right? So group 7A has the highest electronegativity. So your answer should be D. Question 2, number of valence electron for this element. Potassium, group 1A, so 1 valence electron. Hydrogen, group 2A, 2 valence electron. Oxygen, group 6A, then 6 valence electron. Fluorine, group 7A, so 7 valence electron. Question 3 asks you the bond between these atoms. A polar covalent bond or covalent bond or ionic bond. Here you electronegativity of this element. So sodium chloride, the bond between sodium and chloride. So sodium 0.9, chlorine, chlorine 3. So the difference is 2.1. Very big difference. Greater than 2. So this is ionic bond. The bond between chlorine, this is a chlorine gas. There is a single bond there. So these two exactly the same element, then covalent bond. Right? And the bond between carbon and oxygen, carbon 2.5, oxygen 3.5. Difference is 1. So this is a polar covalent bond. The bond between calcium and oxygen, calcium 1, oxygen 3.5. Difference is 2.5. So greater than 2. So ionic bond. So for me, I even don't need to use this electronegativity. So whenever matter bind with non-matter, especially active matter bind with active non-matter, like sodium chloride. Sodium is very active matter, right? Chlorine is very active non-matter. So this is definitely the ionic bond. Sodium lose electron, chlorine gain electron. Similarly, calcium oxide. Calcium is active matter. Oxygen is active non-matter. So calcium lose electron, oxygen gain electron. This is ionic bond. And this chlorine gas is bond between chlorine. So this definitely you don't need to use the electronegativity because this comes from same element. So covalent bond. Carbon, oxygen. Carbon is a non-matter. Oxygen also non-matter. This is polar covalent bond because this come from two different non-matter, right? So polar covalent bond. Question 4 asks you how many lone pairs. So HBr asks you how many lone pairs for Br. So Br, take a look. Br from group 7A. Br from group 7A. So 7 valence electron. Next one is H2S. S is sulfur, group 6A, so 6 valence electron. So Br from group 7A, initially 7 valence electron, but you need to use 1 to form this single bond. So only 6 left. 6 is 3 pairs. So each pair 2 electron. 6 electron, 3 pairs. So your answer is 3. And sulfur from group 6A, so initially 6 valence electron, but you need to use 1 to form each single bond. So use 2 for 2 single bond, then left over 4. This is 2 lone pairs. Okay. Then question 5 asks you which one has highest lattice energy. So lattice energy come from this equation, E equal to K times Q plus times Q minus divided by R squared. K is a constant for similar type of compound. K is the same. So we just compare the charge from cut iron and on iron and the size. So if we compare C and D, both have sodium ion, so cation ion, exactly the same. And on iron, chloride -1, bromide -1. So charge from cation ion on iron. Both compounds +1, -1, exactly the same charge. Then compare size. Size, sodium ion, exactly the same. Then only difference chloride and bromide. So chloride and bromide. As we move down, size becomes larger, right? So bromide have larger size than chloride. Larger size, smaller lattice energy. So sodium chloride will have greater lattice energy than sodium bromide. If we compare A and B, so A, magnesium oxide, B, magnesium chloride. So magnesium 2+ charge. Oxygen, here oxide is -1, -2. Chloride is -1. So charge, this A is greater, 2 times 2. And this is 2 times 1. Right? Don't think this -2 is times -2. We use absolute value because in the ionic bond, always positive charge and negative charge from cation ion on iron. Right? So 2 times 2 is 4. 2 times 1 is 2. So from charge, A is greater than B. Then from size, magnesium exactly the same. Then oxide and chloride, if we take a look at periodic table, oxide from period 2, chloride next period from top to bottom, move down, then size becomes larger, right? So chloride size is larger than bromide. Chloride size larger than oxide. Larger size, smaller in lattice energy, right? So both charge and size tell you A has greater lattice energy because oxide size is smaller. Charge 2 times 2 is 4. This 2 times 1 is 2. Right, so both charge and size tell us A has greater lattice energy. So A greater than B, C greater than D. Then we compare A with C. Which one is larger? So clearly, A charge is 2 plus 2, -2. And C is +1, -1. So this is 1 times 1 is 1. 2 times 2 is 4. So 4 times higher than this. And size, magnesium size is smaller than sodium. Right? If you take a look at your table, magnesium iron, as we move to right, sodium iron, magnesium iron is smaller than sodium iron because these two exactly same 10 electron, but magnesium have 12 protons, so attractive force is stronger. More protons, stronger attractive force. So size smaller. Magnesium is smaller in size. And oxide with chloride. So oxide is here. Chloride is next. So chloride size larger than oxide. So again, both charge and size tell you A will have greater lattice energy because A charge is 2 times 2, C charge is 1 times 1. And magnesium size is smaller than sodium iron size. Oxide size also smaller than chloride size. So size also smaller oxide size, greater charge also tell you greater. So both charge and size tell you A will be greater than C. Then A is the greatest. So sometimes charge tell you A greater than C, and size tell you C greater than A, then which one is greater? Pick the one. Charge, okay. Charge is critical. Charge is more important than size because charge is doubled or tripled or even 4 times higher, and the size is only gradually increase or gradually decrease. So charge is more important than size. Okay. So anyway, this time this question is both charge and size tell you A is greater than C. Okay. So finally, A is the greatest because A greater than B, C greater than D. And compare A and C, A is greater. So A is the greatest. Question 6 asks you draw lowest structure, carbon dioxide. So carbon is less electronegative. Carbon group 4A. Move to the right becomes more electronegative, right? Oxygen group 6A, so in the right side. So carbon less electronegative in center. Oxygen more electronegative surrounded. Carbon initially 4 valence electron. Use 1 to form each single bond, then left over 2. Similarly, oxygen initially 6 valence electron, group 6E. To use 1 to form single bond, so left over 5. So if this single bond, you find oxygen, carbon, oxygen, no one satisfy octet rule. Right? Because oxygen 5 plus single bond 2 is 7. This is also 7. Carbon 2 plus 2 single bond, each single bond 2, total 6. Right? No one satisfy octet rule. Then why not form double bond? So oxygen use 1, carbon use 1, form a single bond, another bond. And the carbon use another one, and oxygen use another one, form another bond. So now carbon no lone pair, but have 2 double bonds. Each double bond 4 electron, 2 double bond 8 electron. For oxygen, 2 lone pair, 4 electron plus double bond 4, total 8. This oxygen is the same. 4 plus double bond 4 is 8. Ammonium. So ammonium initially group 5A, so 5 valence electron. To form each single bond, use 1. So 3 single bond formed, use the 3. Then left over 2, 1 lone pair. Where hydrogen only 1 valence electron. Used to form single bond, so no lone pair. Question 7. Also, you draw Lewis structure for carbonate and calculate the formal charge. For each atoms, so carbonate is a carbon surrounded by oxygen. Carbon in center. 3 oxygen surrounded. Initially, oxygen 6 valence electron. Form a single bond, you need to use 1, so left over 5. Carbon initially 4 valence electron. Use 1 to form each single bond, then 3 used up, only left over 1. Right? And be careful, 2 negative, that means you have 2 extra electrons. So far, we only use these atoms' own electron. Have not used the extra electron yet. So 2 extra electrons. So each oxygen need 1 more because this 5 plus single bond 2 is only 7, right? So we need to use 1 more. So these 2 extra electrons will be assigned to any 2 of these 3 oxygen, but not carbon. Why? Because oxygen is more active non-matter. Strong tendency gain electron, right? So of course gained by oxygen, not by carbon. So we can assign to these 2 oxygen. Then all electrons be assigned. We will check if everybody satisfy octet rule. So this is 6 electron, 3 lone pairs plus single bond 2 is 8. The same 6 plus single bond 2, 8. But this one only 5 plus single bond 2 is 7. Carbon 3 single bond, each single bond 2, total 6 plus this one electron not in the bond. So also 7. then why not carbon use one, oxygen use this one to form another one, becomes double bond? You see, now carbon single bond, 2 plus 2 plus 4, double bond 4. So carbon satisfy 8 electron. Oxygen 4 plus double bond 4, also 8 electron. So this structure satisfy octet rule. Okay, this is the lowest structure for carbonate. Now calculate formal charge for each atom. Since we have 3 oxygen there, we need to label the number. Which oxygen? Carbon only 1, we don't need a label. So carbon, isolated carbon from group 4A, so 4 valence electron. In this structure, is there any lone pair? No. Then how many bonded electron? Bonded electron is shared with others, so we need half. Shared with others, so half of the bonded electron belongs to carbon. Single bond 2, 2, 2, 4, right? Single bond, double bond. This is all shared with others. That's why it's 1/2. So this is 0. O1. Isolate the oxygen from group 6A, so 6 valence electron. How many lone pairs? 3 lone pairs, 6 electron. Then how many bonded electron? Single bond is 2. 2 is shared with others, so that's why it's 1/2 of 2. So this is -1. Then O2 is the same. 6 minus this lone pair 6 minus 1/2 of single bond 2, so also -1. While O3 isolated oxygen always 6, but in this structure, these 4 belongs to oxygen, definitely. And this double bond is shared with carbon, so 1/2 of double bond 4 is 0. Okay. Question 8. Give me bond energy. Hydrogen bond. 436 kilojoule per mole. Chlorine, 243. Chlorine, hydrogen, 432. As you calculate enthalpy change for the reaction, hydrogen react with chlorine, produce 2 hydrogen chloride. So hydrogen gas, there is a single bond between hydrogen. Chlorine gas, there is a single bond between chlorine. And hydrogen chloride, also single bond. So the formula is reactant's enthalpy change is bond energy of reactant. So B bond energy of hydrogen. And bond energy of chlorine. It's a reactant bond energy minus total bond energy from product. Be careful, you have 2 more. So bond energy of hydrogen chloride times 2. Because there's 2 more there. Then you just plug into number. So hydrogen bond is 436. Chlorine bond 243. Minus 2 times hydrogen chlorine bond 432. Use your calculator, you can easily get -185. Okay. Okay, so question 9, that's it. This is the end of semester. Okay, you need to study hard to prepare the final exam.